Hi everyone! Imagine if a burn accident suddenly happens at home, we'd probably be at loss. Can this be handled with just first aid at home, or should the person actually be taken to the hospital right away?
Well, in this video, we're going to introduce an innovative website project called
BurnScreen!
a website designed to help assess the severity of burns and provide appropriate treatment recommendations. You can access this website through your phone or your laptop.
This website uses machine learning technology that runs directly in your browser to instantly perform an initial screening of the burn severity. Not only that, but it also provides first aid guidance based on the patient's age and the location of the burn, complete with a feature to find the nearest clinic based on your GPS coordinates. How does it work and what's the code structure like? Let's dive in!
Before we dive into the code, let's first understand the architecture. BurnScreen was designed as a purely client-side web application to ensure fast response times and protect the privacy of medical data. At its core, this website integrates an image classification machine learning model trained using Google Teachable Machine, which is downloaded into the browser using TensorFlow.js. You can build machine learning model using your own pipeline in Python with tools like Google Colab, VS Code, Spider, and various other software. So choose your side. Furthermore, the analysis of burn photo takes place on the user's device without the need to upload or store the patient's image on an external server. As a result, the process is Furthermore, the analysis of burn photo takes place on the user device without the need to upload or store the patient image on an external server. As a result, the process is secure and the image are not shared. Let's try the website first. The homepage greets us with a modern clean UI. We can drag a photo of the burn here or select a file from a folder. If using a laptop, you can upload the photo of burn area, while when using a smartphone, the website automatically opens the rear camera and uploads from your gallery. Once the image is selected, we enter the burn location and the patient age. This data is crucial because treatment can vary significantly. When you click Start Analysis, the AI gets to work. The system displays a great classification and personalized clinical recommendation. For example, there's a dehydration warning box for children. If the condition is severe, click Find Nurse Clinic. Your browser will ask for location permission, then automatically open Google Maps to search for a clinic based on your GPS location. Pretty handy, isn't it?
Now, let's break down the structure of the program code. We will start with the index.html file, which serves as the website main page. This section includes an image upload area that supports three input methods: selecting an image from a folder, taking a photo directly from the camera, and dragging and dropping a file into the upload area. To support use across various devices, we provide two different file input elements. The first input is used to select an image from the device's storage, while the second input used to capture environment attribute so that the browser on the smartphone can directly open the rear camera. Once an image has been successfully selected, the user will see a preview of the image along with two additional questions: the location of the burn and the patient's age category. This information is later used to generate more personalized medical recommendation provided by the system. Additionally, there is a loader component that appears while the analysis is in progress, a classification result area displaying the burn grade and initial treatment recommendations, and a button to search for the nearest clinic.
Next, let's move on to script.js, which contains the core logic of the application. First, the program defines the URL of the machine learning model trained using Google Teachable Machine. When the page loads, the init function calls tmImageLoad to download and initialize both the model and its metadata, making it ready for image classification. The image upload workflow is centralized within the handle image file function.
This function validates uploaded files, support multiple image formats including JPG, PNG, and HEIC, and automatically converts HEIC image into JPEG format to ensure compatibility with web browsers and the AI model. For direct image capture, the application uses the isMobileDevice function to determine the user's device type. If the user is accessing the website from a smartphone, the native camera interface is launched through the HTML Capture Environment attribute. When the Start Analysis Now button is clicked, the application first verifies that the machine learning model has been successfully loaded. It then executes the model predict function to generate prediction probabilities for each burn severity class. The class with the highest probability is selected as the final classification result and passed to the display result function. Inside this function, the application's medical decision logic is executed. The system dynamically adjusts the badge color, result border color, warning message, and first aid recommendations based on a combination of the predict burn grade, burn location, and patient age category. For example, the recommendations provided for a child with a grade 2 burn on the hand may differ significantly from the recommendations given to an adult with a grade 1 burn on the foot. Finally, the Healthcare Facilities Search feature utilizes the Geolocation API through Navigator Geolocation Get Current Position. The application retrieves the user's real-time coordinates and uses them to generate a customized Google Maps URL, enabling users to quickly locate nearby clinics or healthcare facilities. Beyond its core functionality, BurnScreen also includes several supporting features designed to improve user experience. These features include drag-and-drop image uploads, animated loading indicators during AI inference, smooth page transitions managed by Transitions.js, responsive navigation for mobile devices, and a modern user interface built with responsive CSS design principles. Together, these components create a seamless and user-friendly experience across both smartphones and desktop computers.
The BurnScreen project is a real-world example of the collaboration between AI and healthcare for WebRTC. However, please remember that this website is intended as an initial screening tool and not a definitive diagnosis. Always consult a doctor first if the injury is serious. That's all, and don't forget to like, subscribe, comment, and share this video. Bye-bye!